Hi, everybody. Welcome to the BiocSwirl Project's Lightning Talk. I'm very excited to be introducing you all today to our R package. So essentially, our R package builds entirely on the Swirl infrastructure and course format. Swirl is an R package where you can generate different R courses. And so R courses particularly cover just bioconductor workflows and analyses and different packages as well. So these courses are done entirely through your R console. It's very similar to, say, a data camp course if you've ever done anything like that. And we started basically as a hackathon project that's been going for about 2 years now. So I wanted to get right into the footage so you can see kind of what the course is like and what it's about. So if I increase the quality here. So currently, we have students installing our courses through DevTools. Basically, you just install the R package using the install GitHub function. And one of our main dependencies is, of course, Swirl. And so you can see here that we have a variety of courses. The student is currently going through the RNAseq course, and it lists the lessons, all of the inherent Swirl functionality. It also works in BioSwirl. So if you've ever done a Swirl course, very similar, you'll be able to jump right in. And you can see that we have different students at the first lesson of each course, installing the different dependencies and learning how to install packages with Biomanager. Of course, if you have the dependencies already, we're just going to load it in the background for you. And if you skip it, we'll be running the commands in the background so that you don't have to worry too much about running into errors, for instance. So if we go into what an actual course might look like, this is our PCA lesson in the RNAseq course. So currently the student is trying to generate a label matrix just to use for the heat map mapping, just so that they have the labels. And you can see here that the student has run into like a very small typo. Basically, they kind of did their first intuition, which was use a function called matrix. However, because the actual syntax is as.matrix, you can see that we have given them a wrong answer and instead suggested the correct answer. And through that adjustment, they're able to do what was needed. If we skip a little bit more forward here, we're just getting them to go through the vignettes so that they know what we're using. Currently, our course incorporates pHeatmap. And now they're going to be trying to generate their first heat map. You can see here that their first instinct, again, was to use the pHeatmap function. And then as they're going through, you can see that in this particular case, we have given them the actual command to run. And so this is typically because, with a long command such as this one, it can span multiple lines. There's, sometimes typos that occur or bracketing errors. And so students oftentimes find it very nice to be able to directly compare the answer. And this is really nice as well, just because, it helps pad some of that anxiety as well. So this student is going to now try and, I guess, copy and paste the answer to the question, but it didn't necessarily work. So now they've got a heat map kind of going, but it's obviously not very nice. It's not what we're looking for so far. So they're making adjustments as they're going along. Our error messages are going to be popping up, but we're also going to be giving them hints as well. So this is sort of like a guided troubleshooting, if you will. And this will be accommodated to kind of their level. So now they've got the heat map to display correctly. However, they're missing the labels, so they're having to do some adjustments. And now you can see that they have exactly what we were looking for, and they're going to be asked to interpret it. So because the view is a little bit small, they're going to make it larger. And now they're going to be looking at this plot and answering some of the questions that we've given them. All of our courses use standardized data sets that are publicly available, and we're trying to pull information that's already pretty readily available online. We're not trying to reinvent the wheel. Most of the aim is to teach them, why or how we use certain functions and what the workflow is at more of like a holistic level instead of just giving them code to copy and paste. This is really helpful if you're trying to learn an analysis for the first time, particularly to apply to your own data, right? So next, we're going to be continuing on with this lesson. And we're just going to be showing what it's like to learn some of the more statistical concepts and theoretical concepts. Currently, we're having the student here go through DESeq2. As you can see, the environment has been set up for the student. This is usually done as they're going through the course, just as they're running this R code. But say if a student wants to skip ahead to a particular lesson, they don't want to do the first 3 lessons, or they've done it before at some other time, then they don't have to worry about having to backtrack constantly. And it also helps us keep a controlled environment so that we can work on that troubleshooting a little bit more. So right now, they're going to be working with DESeq objects and playing around with the results table a little bit and seeing, what it is exactly and how to manipulate these different data frames that they're being given. So if we skip ahead here a little bit, we can see that the information is also provided in bite-sized chunks. And this is really helpful when you're trying to wrap your head around some of these new concepts, and it makes it very easy to kind of jump in and feel like the pacing is continuing on. So now that we've got a nice little results table, we're going to be asking the student to interpret some of these numbers that they're seeing, as well as reading this column. All right. So now that they're working with summary objects, you can see that obviously this kind of footage is sped up a little bit because it would be too slow to do it in real time, but it is entirely self-paced. Now they're going to be filtering these results for significant p-values just so that they can actually get to the stuff that we want, right? Which is, which genes are more expressed or which genes are, less expressed throughout the experimental conditions, and they're adjusting for different p-values. I think that one of the really interesting things here to look at, of course, is that, we have this positive feedback that's coming in, and that the student is able to really, not have to read this giant body of text and kind of, have all this theoretical information that's floating around in their head. They instead can kind of do it and break it up and have these hands-on components, which make it a lot more fun for active learning. So now the student is just going to be taking away their results and interpreting them. So I'm going to be moving on to the next few slides now that you know exactly what it is that BiocSwirl looks like if you've never been exposed to a particular course like this. So one of the things that's really interesting about BiocSwirl is that it's asynchronous, but we're trying to incorporate a lot of these active feedback components. Of course, the gold standard for learning these sort of workflows is workshops, right? But workshops can be, a little bit disruptive to your schedule, and it can also be very expensive. So we wanted to create an open and free option that's very easily updatable, that the community can kind of contribute to in a lot of different ways. And that's something that you might find a little bit different from, say, a book down tutorial, for instance. Of course, our courses are meant for people who are new to coding, particularly those who are coming from, biological or wet lab backgrounds and who maybe have a little bit of code anxiety too. And we want to make this information accessible just in case, somebody has funding difficulties. Other applications that we've used for this particular format has been hybrid workshops. These have been really nice, part lecture, part hands-on. We also think that undergraduate courses could really benefit from, something like this. As well, we think that down the line, creating interactive documentation for packages would be really helpful as well. So these are our current course offerings, all in sort of different stages of development. I would say our most developed course so far is the RNAseq workflow, and all of these courses can be done independently of each other. We do want to, of course, add more down the line. And I also want to thank the development team who've been working so hard over the last 2 years. That's me right over here. And we're always looking for new developers. If you're interested in getting involved at all, please do not hesitate to reach out. We are a really nice team, and we're very keen on having beginners who want to get involved in open source as well. So you can find us through these links. On Twitter, we are at BioCTools. Our GitHub repository is under the organization BioSwirl dev team. And our website is bioinformaticstutorials.github.io. So thank you so much, and hopefully we can see you soon.